1.4, B as in boy, continuing with example 6 on page 106. Now I had mentioned doing example 6 using the point-slope equation, and then at the end I had mentioned you could use the slope-intercept equation. So let's do that, top of page 107. We had found out that our slope was 7 using our difference in y over the difference in x. And we have points 2, 3, and we have points 1, negative 4. Okay, so what we're going to do is we can choose which of these 2 points we're going to use in our y equals mx plus b, because again, in order to solve this we have to find the slope and the y-intercept. Well, we have the slope, so now we're just looking at finding the y-intercept. So what we have to do is we have to plug either the 2 and 3 in for the x and y, or the 1 and negative 4 in for the x, y. And what that'll do is we'll have a number here, a number for slope, a number for x, and we'll have b is what we're looking for, and that's what we need. So if I use 3, I'm going to, 2, 3, I'm going to have 3 equals 7 times 2 plus b. Or if I use this one, I'm going to have negative 4 equals 7 times 1 plus b. So let's just use both of those. So 3 equals 14 plus b. So that means we have negative 11 equals b. And if we use this one over here, we're going to get negative 4 equals 7 plus b. Subtract 7 from both sides, and we also get negative 11. So either one you use, either point you use, whether you choose this one or this one, you're going to get the same y-intercept, because it's the line goes through this point or this point, so therefore it has to go through the same y-intercept there. Alright, so the next section here is on parallel lines. So let's get rid of some of this stuff and focus on parallel lines. Okay, so can we determine whether the graphs of 2 linear equations are parallel without graphing them? Well, all you have to do is know what the slope is. If the slopes are the same and they're non-vertical, then all you have to know is that the slopes again are the same and they have different y-intercepts. Meaning, if our y-intercepts were the same, if it went through, let's say, this point right here, and then I had another one that went through the same point, well, if the slope is the same and the y-intercept is the same, it would be the same line. Okay, so those would not be parallel. Parallel means they never cross. They do not have any points in common. So therefore, the slope can be the same, but the y-intercepts must be different in a non-vertical line here when we're talking about parallel. Alright, when we're talking about perpendicular, the key thing to remember is making sure that your slopes are, let's get rid of this, that your slopes are the opposite of the reciprocal. So, if I have 3 as a slope for one line, then the perpendicular would be the reciprocal with the opposite sign. If I had negative 1/4, the opposite would be a positive. Reciprocal of 1/4 is 4 over 1, so it would be 4. So if we have the negative reciprocal or the opposite of the reciprocal, then we've got perpendicular lines here. So if you look at example 7, on the bottom of page 108, we have y plus 2 equals 5x. And we also have 5y plus x equals negative 15. And they're asking us to determine whether or not they're parallel, perpendicular, or neither. So first of all, we have to put both of these in slope-intercept form. I'm sorry, this is needs to be a better equal sign. Y equals 5x minus 2, slope-intercept form. 5y equals negative x minus 15. Divide both sides by 5. And we have y equals negative 1/5 minus 3. Okay, so what we're going to look at is the slope only. So we're looking at that number and that number. Well, the two are negative reciprocals of each other, so therefore they are perpendicular. Okay, when you look at letter B in example 7, you'll see that the slopes are both the same once you put it in slope-intercept form, so therefore they're parallel. And if you look at C, you'll find out that not only are the slopes different, but they also are not negative reciprocals. So therefore, they are neither parallel nor perpendicular. So they may, if this were my graph, one may be here and one may be here. So they're not parallel and they're not perpendicular. They just cross at one point. So example 8 on page 109 says write equations of the lines A parallel and B perpendicular to the graph of the line 4y minus x equals 20 and containing the point 2, negative 3. So what they're asking me to do is to take the line 4y minus x equals 20. And they're asking me to draw or come up with an equation of another line that is parallel to this line and goes through the point 2, negative 3. So, for instance, if I had, this is just an example, if I had a graph, and let's say 4y minus x equals 20 looked like this. It doesn't, but if it did, it would look like that. They're saying, okay, now come up with the equation of a parallel line that goes through 2, negative 3. So it goes through a point right here and is parallel to this line right there. So I'm trying to come up with this blue line here. I'm trying to come up with the equation of that line that goes through the point 2, negative 3, and is parallel to the red line. So that's what I'm going to try to do. So here we go. First of all, we need to find the y-intercept and the slope in order to get this equation together. So first of all, we're going to take that one and write it in slope-intercept form. Then we're going to divide by 4. So the equation that they gave us, okay, looks like that. And let's see if I can clean this up, make that look a bit more like a 4 here. Alright, so the slope of this equation is 1/4. The slope of our new equation, since they're asking us to come up with an equation that's parallel to this, is also going to have a slope of 1/4. So what we're going to do, the book gives you an option of either using the slope-intercept equation or the point-slope equation. Now when they do it, they use the point-slope equation, and you can see what they did there. I'm going to use the slope-intercept form just to give you another way of doing it that the book doesn't show. Well, I know that the slope of my new equation is going to have a slope of 1/4 because it's parallel, so that means the slopes have to be the same. I've also been given this point right there. So what I'm doing is I'm trying to take this equation like that and make an equation that is parallel to this one and goes through this point. So y equals, is going to have the slope of 1/4 x plus b. So now I'm trying to find b. I'm trying to find the y-intercept. So I'm going to plug in negative 3 for my y. And 1/4 times 2 for my x. Okay, so negative 3 equals 1/2 plus b. Negative 3 minus 1/2 equals b. So I get negative 3.5 or negative 7/2 for my b, which gives me an equation of y equals 1/4 x minus 7/2. That is an equation that is parallel to this one because the slopes are the same, but the y-intercepts are different, and that's what has to be the case when you have two parallel lines. Alright, now if you wanted to go and find the perpendicular, you can use again the point slope equation or the slope intercept form of the equation, but we're going to use the slope intercept form of the equation again. So let's rewrite this in slope intercept form, which we had in the last one. Y equals 1/4 x plus 5. Okay, so now what we're doing is we're making a perpendicular equation that goes through this point. So we know perpendicular is going to give me a slope of -4 because of the opposite reciprocal or negative reciprocal, and then we'll plug in our y value for y, -4, our x value for x, plus b to find our y-intercept, so our b equals 5. So our slope is 4 and our b is 5, so we can write that as y equals -4x plus 5. And that will be the equation that is perpendicular to this equation and goes through that point. Okay, that is it for 1.4. We're not going to go into regression, line of best fit, that kind of thing. We'll be getting into that a little bit more later on, and so we're going to avoid curve fitting and that kind of stuff for right now, and we'll hit that later. Alright, so that's it for 1.4.